So in addition to whales, we're also interested in birds. As I said earlier, keratin is the main protein in both whale baleen and bird feathers. So we can actually use the same method to analyze PFAS in both. I have here feathers from 3 species of penguins in the Antarctic Peninsula. Gentoo penguins, emperor penguins, and Adelaide penguins. These were all collected in 2013 from across the Antarctic Peninsula. They're quite a lot smaller than I thought they would be. These are the Gentoo penguin feathers. So we can take these and extract PFAS from them. We want to see how much PFAS is in these feathers, and also what kind of PFAS. So there are about 15,000 different individual chemicals that make up the class of PFAS. And what kind we find tells us a lot about where they came from. So the Antarctic, it's pretty remote. There's not a lot of ways PFAS can get there. So what kind of PFAS we find tells us how they got there. We have actually already analyzed these feathers. We found a lot of short chain PFAS. Short chain PFAS means that it came from manufacturing. These are emperor penguin feathers. Short chain PFAS means that these chemicals were produced far away, most likely North America. There's not a lot of industry in South America, and then transformed in the atmosphere before reaching Antarctica. I said earlier PFAS don't react in the environment, and that is a half-truth. There are some chemicals that are more reactive than others. 15,000 chemicals, there's a lot of them. Some are more reactive than others. And they can get into the atmosphere. And in the atmosphere, weird chemistry goes on that is actually powerful enough to break apart some of these PFAS into short-chain carboxylic acids. And that's exactly what we found in these PFAS. These are Adelaide penguin feathers. You'll notice they are all almost identical. All of these penguins are closely related. They're all Gentoo and Adelaide are the same genus, and emperor penguins are also closely related. They all feed on just about the same thing. These were collected from a few different research stations on the Antarctic Peninsula, all within about 100 kilometers. They all feed on more or less the same organisms. So we didn't expect to see a major difference in PFAS, and we didn't see a huge difference. Bioaccumulation is when chemicals like PFAS accumulate when you eat something through food. In the environment and among animals, that tends to lead to bioconcentration, where these compounds get more concentrated as you go up in the food chain. So Adelaide penguins and Gentoo penguins are fairly small. I'm going to say about yay big. They don't eat a lot, so they had significantly less PFAS than the emperor penguins. They're large penguins. They eat a lot more on an individual basis than either Gentoo or Adelaide penguins. So we expected to see higher concentrations of PFAS in emperor penguins than Gentoo penguins and Adelaide penguins, and that's exactly what we saw. And we did expect to see some indications that research stations along Antarctica were contributing to PFAS, and we did not. That actually was a good thing. The Antarctic Peninsula has a high density of research stations, so you would expect to see something from these research stations, yet they're not producing the PFAS we thought they were.